A building facade, as the image of a building, is not only important to enhance the aesthetic value, but also to control the daylighting performance of a building. The design emphasizes the dynamic louvers as the building facade to control the daylighting performance by responding to the dynamic daylighting conditions. Natural daylighting should be brought into the building spaces, but we always live with the electrical lighting. We study, we work with the lights on, and even in the daytime. And one of the main reasons behind the issue is the poor facade design. The design aims to integrate the responsive louver automated shading system to enhance the usual visual comfort and improve the building's energy efficiency. The facade design is inspired by the bookshelf in the library. It looks similar to the typical louver system, and we can customize the rotation angles and the materials, and the trees can be integrated as a passive shading strategy. And we can also open the louvers and get interacted with the outdoor environment. Learning is the core value of the library. The architecture is inspired by the habit of reading books. The tree grows from the book symbolizes the knowledge we gain from the book. The lush greenery as the identity of the building expresses the wealth of knowledge in the library. The ground floor is raised, while the sub-basement is used for the car park and services. Preserve the existing vegetation and extend the greenery into the site. Daylighting can penetrate into the sub-basement through the skylight. Building blocks are allocated between the greenery to enhance the interaction between the greenery and the users. Create a gap between the floors to let the prevailing wind flow through the site, and design the amphitheater seating for the auditorium and reading spaces. Control the height of the form to enhance the visual connection to the surrounding view. Push the blocks inward for terraces and greenery. Integrate the overhangs and dynamic facade to control the daylighting performance. The site is located at Bukit Senyum, a suburban area in Johor, Bahru, a highly visible spot where it is situated adjacent to the highways. The existing route is used as the service access to the building services and loading-unloading area at the sub-basement. The lush green landscape provides a common space within the site context. Minimize the vehicular circulation of the site and connect the existing pedestrian walkway to the site, while the generous frontage design creates a sense of welcoming to the visitors. The building is oriented according to the geometry of the sun, and the gaps are created within the building to improve cross-ventilation. The design takes the opportunity to link between the PDRM and the library. Linkages are also designed to connect the public spaces within the building. The reading space is extruded as a prominent feature and overlooking the highways. The public spaces are located on the ground floor to enhance the public accessibility. The double volume design can help to improve the daylighting distribution in the spaces. And the green courtyard is served as a common space to celebrate different activities and functions. Skylights are introduced at the convention hall and gallery, while there are also the design features at the rooftop garden. The steel structure to support the extruded form, and the gaps to improve the airflow between the spaces. And the partition design provides the flexibility to the reading spaces. computer simulation has been carried out to study and evaluate the performance of the dynamic building facade. Of the optimal facade configurations have also been identified from the simulation process. Ergonomic and anthropometric of the human body have been measured in the design process, while the recursive rules are also implemented to further develop the louver's dimensions, to better understand and design a facade that fits well with the human scale. The sensors will measure the light and heat levels of the outdoor environment, then transfer the data to the central processor, and activate the dynamic facade and other smart lighting devices, while the users is another source of input to control the central processor. Steel as the lightweight material is integrated as the facade structure to reduce the building dead load. Service access is integrated with the structural design to ease the installation and maintenance work, while it also functions as a light shelf to reflect the daylighting from the outdoor into the indoor spaces. The motor and the actuator are integrated into the facade structure to perform the dynamic rotation. The louver can be replaced with other material to provide different lighting effect to the interior spaces and different function to improve building's energy efficiency.